Hey, what up, boy? This is your math teacher here, Mr. Dominic, coming at you with another math video. Yeah, no, I can't do that. Sorry. Whatever tutorial, video game, and all that stuff you guys got. Nope. Sorry. I tried. All right. Here we go. We're coming at you with slope today, though. Okay. Our last one for this time. Talking about slope. So hopefully you did the other video already, which has to do with the coordinate plane. Okay, and the different sections are on it. 1, 2, 3, and 4, right? The different sections of coordinate plane. You have your coordinates, x and y, right? They tell you where to go. It's like directions, right? X and then y, and you have your dots on a grid, right? And then you got a grid that you're graphing on, okay? So what we're doing with all of that now, though, is... Can I erase all this? Oh, okay. What we're doing now, though, is talking about slope. What slope is if you have a graph, like you were talking about, okay? Slope, and you have a line on that graph. Slope refers to basically how steep that line is. Okay? A big slope means a steeper line. A small slope is a shallow line. Okay, and you can go small. It can go into the decimals or the fractions. Okay, you can go pretty tiny. That's how we're talking about for shallow. So if I had a slope of like 4, okay, that'd be pretty big, right? If I were to have a graph here, we'll draw it in green. The grid in black that I drew is a 90-degree angle, right? Right in here, right? That's a 90-degree angle right here in that graph. So if I had a line that was there, that would split that perfectly in half like this, okay? 45 degrees basically, right? That straight angle. That is a slope of 1. Okay? So a 4 is pretty big. That means I'm going pretty steep like that. Whereas a slope of like 1/5, that's pretty shallow. I'll draw that in blue here. That's going to be something like this. Not going to be nearly as steep. Okay. So that's basically what it tells you. That's the information it gives you. Okay, how steep your line is, and the bigger, just by looking at the number, if you tell me what the slope is as a number, I can tell you in my mind what that looks like as a graph because of how steep or not it is, how angled the line is. Okay, so this has many uses. Okay, ski slopes. It's literally called ski slope, isn't it? Okay, it has to do with the angle of the trails and the mountain that you were skiing on. Okay, they use it as a judgment of safety. A lot of applications of slope has to do with safety, right? So they know what to rate that trail, okay, so that they can give it a proper safety rating. Ski slopes, you have it. Wheelchair ramps, there's regulations, okay. There's a certain degree at which the ramp can't be too steep, because if you think about it, right, if the ramp is going up this way, if that ramp is really steep, you're not going to be able to get up it, right? The angle is not going to be easily to go up for a normal wheelchair. So there's regulations on that. The pitch of your house. Okay, pitch is kind of another word that they use for slope and steepness. Pitch of the house, the angle of the roof, that has to do with slope and tell you the angle at which it's going up or down. Your stairs, there's regulations about stairs, about how steep it is. I mean, think about it. Think about how hard it would be if your stairs, if they were a high slope, right? That'd be a little ridiculous to try to climb stairs like that. So there's regulations about that, about how steep that is for a slope. I just know it offhand, you know. I know in NASCAR driving, right, that it looks like it's just a flat oval that they drive round and round and round in, but the side of the track is angled quite a bit because that's a safety thing as well to make sure it can take the torque of the cars going around. Right, so there's lots of applications. A lot of it has to do with safety and regulations for slope. So let's talk about finding slope. Okay. How to find slope. All right. Again, if you tell me what a slope is, I can tell you how steep that represents, and hopefully you guys are getting an idea about that now. But now, like, what if you're not given it? What if you're just given some information, you have to find it? Well, again, slope comes from thinking about a graph. Okay. If I have a line on that graph, our job is to be able to find the slope of it. Let me just see here. Yeah, I got it coming up. Okay. So I want to be able to know what's the steepest. How do I go from one to the other? Okay. How do I go from one to the other? Like stairs. Okay. Pretend like I'm drawing stairs all the way up here. I want to know what is this change. Okay. Let's pretend there's a dot right here and a dot right here, let's say. Okay, I want to know what is the change to go from this first dot up and then over, like I'm building a stair, to the next dot that I drew. And then if I put another dot on here, it will be the same for that whole line. Every slope should be the same. But again, you're thinking about what is it? What are the numbers that gets me from one point up and over to the next point? Up and over to the next point. And so on forever. Okay, on that line. Up and over, up and over, up and over. Okay, so that's what you're looking for. Okay, you're asking yourself, go up and over from one point to another. Okay, here's the thing though, up and over is not a very mathy word. Not very mathy, right? Sometimes math has to be a little bit more difficult and be a little bit more formal with what they have to say. Okay, what we use though is what's right here, rise and run. Okay, so the up, going up is called the rise, and the over is called the run. So it's not terribly difficult. They didn't make it some weird random Latin, Greek-based word there, right? Rise and run. Okay, that's kind of the same as up and over. But that's how you do it. Okay, you just count. You think about it on a grid like we have in this picture here. I'm going to erase some stuff here. Okay, get out of here. Okay, so on this picture that I have here, we have rise and we have run. And you see here's a dot and here's a dot. And you're going from this dot up and you're going one. I'll actually mark it on here. 1, 2, 3, 4 blocks. Right, you're going 4 blocks up and then over 1, 2, 3 blocks over. It takes you have to go up 4 and then over 3 until you get to the next dot. Now you can't just put a dot anywhere you want on this. I couldn't just put a dot right here. I guess you could, but that wouldn't be really helpful because what is this? I don't know where that is. What you want to do is you see how this blue line, let's see if I can make this more obvious here. Okay, this blue line going like this up through, fill in those where those black dots already are. If you think about it, this blue line would have crossed this grid exactly in the corner right here. That's why they chose that black dot. Okay, same thing here. Okay, if that grid is filled in, it would have crossed it perfectly. That's why they chose those 2 points. Okay, I couldn't choose right here because it doesn't cross that grid perfectly. Right here is a perfect crossing, and right down here is a perfect crossing, but the line doesn't go through those. Okay, you have to pick exactly a point where it goes through. And then all you do is literally count up and over, and then you make it into a fraction. It's called rise over run. Okay, and they usually use the letter M to represent it. Okay, so M, which is slope, that's the letter in math that represents slope pretty much all the time. Slope is rise over run. So the number of squares up over the number of squares left or right. Okay, and we'll talk about which way you go in a second. Okay. So in this case, you go up 4, rise 4, run 3. That's your slope, 4/3. Done. It is that easy. Okay, 4/3. That's it. Count up, count over. Do I have? Perfect. Okay. So right here on this one, notice how you have dots already. They didn't put a dot right here because it doesn't cross at a perfect corner of the square, of the grid. Okay. 2 dots they already have here and here is because they would cross perfectly in a corner. So that's what you have to do. You have to choose those ones. Okay. So now, to find the slope of this, it's pretty easy. Go from one dot to the next. I always start on the left side. Okay. This is the leftmost. And I'm just going to go, remember, you want to go up. You want to do the rise first. Well, in this case, I'm not going up, am I? I'm actually going down. So we're going to say up or down. Either one's okay. You want to rise, up or down. But since I'm going down, I'm going to go 1, 2, 3, 4, 5, 6, 7. 7 blocks down. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks over. So my slope, right, I said rise over run. So the rise, which is up and down, okay, rise equals up or down. And the run means left or right. So I went 7, and then I went over to the right 9. Okay. Here's the one difference, though. Because I went down means negative, right? Which isn't that hard of an idea, because usually when we go down in temperature or we go down in the number line, it means negative. Okay. And then left means negative. Okay. So I have to include those now. So up is positive, right is positive. That's what I did in this first graph. I went up, and then I went to the right. So those are both positive, so I didn't need any symbols. 4/3 was it. But here, because I went down, I have to put that as a -7. That's all. Not a big change. I went down 7, so I put a -7. And I went to the right, 9, so that doesn't need to change because it's a positive number. I don't need to put a plus here to show that it's positive, right? We don't do that with positive numbers. We only have to put a symbol there if it's negative. So technically, my slope right now is -7/9. Okay? So I'm going to erase some on this so I have some more room. I'm going to draw another line on here. And we're going to see what happens. Okay? Probably draw a couple. So we'll go, let's go right here. Okay, and we'll go up. Okay, try to draw it thicker. But there we go. So now, first thing I gotta do, I'm gonna give you a second. Look and see. Where does it cross exactly in a corner? Okay, so if you look and see, hopefully you picked out this spot right here. That crosses exactly in the corner. This one looks right here, looks close, right in this origin in the middle, but I don't think it crosses exactly in the corner, so I got to keep going. This one, no, it's close. This one, yeah, that's pretty much it. That's as best as I can draw it to actually cross. Okay, so we're going to go with it. We're going to go with that one. Those are two. Okay, if I had a ruler, it would come out better. So now I can check out my slope. Again, all we got to do is count rise up and down. I'm going to start at my leftmost dot, which is here. Go 1, 2, 3, 4, 5. I went up 5. Okay, because now if I go over, I'll be in the same line. Then go over, so the rise is 5. 1, 2, 3, 4, 5, 6, 7. I went over 7 to the right. They're both positive, so I don't need to put a negative symbol on either one. Okay, but if I went down anywhere, okay, let's say I started at this dot right here. Instead of starting on the left side, I'm going to start over here on the right side. I'm going to start right here, and I'm going to go down to this dot over here. So I would go down 1, 2, 3, 4, 5. So I went down 5. So technically that means negative 5 because I went down. Now I'm going to go to the left. And remember, left also means negative. 1, 2, 3, 4, 5, 6, 7. So I went to the left 7. So that means negative 7. Well, from the beginning of the year, negative divided by negative, they cancel out. And I still get 5/7. Okay. So it doesn't matter which dot you start at. For me, again, it's just a visual thing. I like starting at the leftmost dot and then going over. Doesn't matter. You're going to get the same thing if you do it right. All right. So that's doing it on a graph. Last piece here. Okay. Well, actually, we'll get to the last piece after this. There are 4 types of slopes, though. Okay. Negative slope right here, you're going to get a negative number. So, like, I had negative 7/5. No, 7/9. I had negative 7/9 as a slope a second ago, I think. Okay. Negative slope. That means my line goes down like this. Okay. Steep, shallow, doesn't matter. It's going down like this one. Okay. Positive slope. Any positive number at all. 4. Okay. What did I just have? 5/7. That's positive. Goes up. Shallow, steep. Okay. Whatever. It just goes up that way. Okay. It's like you're climbing upstairs, going up. Negative slope means you're like skiing down. You're going down. You're like, ah. Okay. Maybe you got some negative feelings going on. Then you have no slope. You're just flat, like cross country skiing. Okay. You're just going straight across. It's a flat line. It doesn't go up. It doesn't go down. It's just straight across. And then finally, the big no-no is undefined slope. Okay, that's this one. Okay, imagine skiing down that. You're just free falling. Ah, worried face. Okay, you are free falling straight down. So it's undefined because there's no way to actually do that. You just fall. Those are your 4 different types of slopes: negative, positive, none, and then undefined. Finally, okay, the last piece that you're going to have to do is find slope without a graph. Slope. You have to be able to find slope without a graph. If I just give you coordinates, so you don't have the visual going on. Okay. I'm just telling you where 2 dots are on a graph. Okay. So let's say X, Y, right? Let's say we have a dot that is at 2, 3, and another dot that crosses perfectly at -1, -4. Okay. So You could put this on a grid and count the squares, but that takes a lot of time sometimes. So what we're going to do, again, what we still want to follow that rise over run. Okay? All we got to do is count. Just count them without a grid. Okay, but just count from one number to the other one. Count from this coordinate to that other one. Okay? So rise. We either need to go from X to X or from Y to Y. Right? It doesn't make sense to go from X to Y. Those are two different types. So these are our Y's. And these are our X. So which one do you think represents rise? Y or X? Which one goes up and down? That's going to be Y. Okay, the Y is your rise. The run is your X, because Y is your up and down, and your X is left and right. So do that. All I got to do is start here at 3, and how much does it take to go down to -4? 3 down, not really writing well, down, what is going on? Back off. Down to -4. Okay, well, 3 down to 0 is 3, and 4 more. You went down 7. So don't forget, down means negative. So I went down 7. Now, what about the X? I'm going from 2 down to -1. How many is that? Go down, boom, boom, boom. You went down, so again, down means negative. So I went down 3. Well, look at that. They're both negative, which means they cancel out. That means my final slope is 7/3. Done. Okay, that's it. That's finding slope from two coordinates. Just take your y's and count from one to the other, and take your x's and count from one to the other. Notice though, I started at this one right here. Okay, I went from 3 to -4, and I went from 2 to -1. Okay, whichever one I started, I have to continue to start there. I can't switch. Can't go from 3 to -4, and then from -1 to 2. Doesn't work that way. Whichever one I start at, that's where I do for both of them. That's it. Okay. So check out the video again if you need to. Go through things, see how it goes. Hopefully it's not too bad.